All right. So last class we started 4.3 and 4.2, but we didn't really do 4.2, but that's okay. So increasing and decreasing, and relative, how to find relative extrema. So we talked about when a function's decreasing, when it's increasing, and when it switches from decreasing to increasing, where the derivative is zero, that's where we have our relative extrema. So to find where the function's increasing or decreasing without looking at a graph, we take the derivative because the derivative tells us the rate of change. Wherever the derivative is positive, the function has to be increasing because the slope's positive, the function is getting bigger. Where the slope is negative, the derivative is negative, this function is decreasing. So we took the derivative, find the critical number, so where it's zero and does not exist, that's where it could go from increasing to decreasing. So we tested to see if it was going from increasing to decreasing or decreasing to increasing by plugging in numbers in each interval. If we get a positive number, we know that if the derivative is positive, the function is increasing. If the derivative was negative, that means the function is decreasing. And if we have a sign change, we must have a relative max. And if it goes from decreasing to increasing, we got to have a relative min. So we looked at that a few times. I think we did an example. Yep, we did this one example. Find the relative extrema. So take the derivative, find out where 0 does not exist. So those were the critical points. Once we had our critical points, we made a sign chart and we tested points inside of each interval to find out if it's positive or negative. And if it goes from negative to positive, we have a min. If it went from positive to negative, we have a max. Negative to positive, we had a min. And we found out where they were by plugging them into the function. So that's like the short of what we did. We're going to do at least one or two more examples, 1.5 more examples, and then I'm going to have you guys start doing practice problems. So last class, we started off with this function, x to the fourth plus 1 over x squared, and our goal was to find the extrema. So we started off by taking the derivative, and that's where we stopped. All right. You guys ready? Recap is over. Ready for the next episode?
I'm ready.
Of course, sir.
All right. Here we go. Okay. So we have the derivative, and I want to find the critical number. So I need to find out where the derivative is 0 or does not exist. So let's find out where the derivative is 0 and the derivative does not exist. So if I want the derivative to be 0, I need to set my derivative equal to 0. So if the derivative we got was 2x to the fourth minus 2 over x cubed, I want to find out what x value is at 0. So I really just need the numerator to be 0. You can think multiply both sides by x cubed if you want. Algebraically, you can think of it like that. But really, I just need the numerator to be 0. So 0 times x cubed is still 0. So that's the numerator. So add 2 to both sides. 2x squared equals 2. Divide both sides by 2. We get x squared equals 1. So x equals plus or minus 1 is where we have critical numbers. Where does the derivative not exist? So that's when the denominator is 0. So when does 2x to the fourth minus 2 over x cubed not exist?
Are you asking us
Yes.
right now?
This is me asking you.
When x is 0?
Mm-hmm. Now here's a problem. 0. So the plus or minus 1 are critical numbers. X equals 0 is not a critical number.
That makes sense.
Why is it not a critical number?
Because when you take the derivative and then you equal it to 0, it's not a solution.
So it's not. So let me go back to what we define to be a critical number. I believe it was in this section. So one more up. This is what we define to be a critical number. The function has to be defined, and the derivative has to be 0 or not exist. Now, in the case that we're looking at, if you plug in x equals 0, the derivative does not exist. That is criteria for a critical number. So just because the derivative doesn't exist at C, that's not the reason why it's a critical number. Or that's not the reason why it's not a critical number. The reason why it's not a critical number is because of this right here. The function needs to exist at that point. Go back to this original function. 0 doesn't exist in my original function, right? You can't plug 0 into f of x because you'd be dividing by 0. So x is not a critical number because the original function f of 0 does not exist. All right,
that makes sense, yeah.
It's a little tricky because all it is a little dash mark, but we want, if the derivative doesn't exist, that's a good thing. That means it's probably a critical number, but the function has to exist at that number, even though the derivative doesn't. And if the function doesn't exist, then it's not a critical number. It's not even defined in our function. So it's a little bit tricky, but that's kind of what's going on there. Another thing to kind of pay attention to is when I did this set the derivative equal to 0 part, if I didn't simplify, because if you guys remember, this is what we got for an answer, and you could divide out an x and simplify it to this. If we didn't do that, and I wanted to find out when 2x to the 5th minus 2x over x to the 4th equals 0, then when I set the numerator to 0, we would want 2x to the 5th minus 2x to equal 0. And here we would actually have to factor out a 2x first. And then from here, we would have got x equals 0, and x equals 1, and x equals -1. Now, 1 and -1 we already agreed on is a critical number, but we would have missed x equals 0 here. So when you divide out the x on the top and bottom, you're losing a possible factor. And it turns out x equals 0 would have been, it would have made the derivative 0, but it also would have made the derivative not exist. So we still caught that number here. So just something to be careful for, or just something to be kind of like aware of, that something like that could happen. We still ended up getting x equals 0 when we set the denominator equal to 0. And luckily there was still another factor of x in here, so that when we divide, we could still realize that we can't divide by 0. If I had something weird like x squared over x, this would be a tricky one, because if you leave it alone, then the derivative would not exist at x equals 0, because you'd be dividing by 0. But if you simplify this to just x over 1 or x, you might not realize that the derivative doesn't exist at x equals 0, but the derivative would be 0 at x equals 0, so you would still kind of catch that value. So what I just spent the last 5 minutes talking about, if you didn't quite catch it, that's okay, because it's not going to be an issue for us. But if you did follow it, it's just something interesting that being aware of it won't hurt. Okay. Anyways, so I'm just going to get rid of that. I don't want you to get more confused than you have to be. All right, so we found the critical numbers. Now, what I said is plus or minus 1 are critical numbers, and 0 is not a critical number. However, when we make the sign chart, we need to include 0, because even though it's not going to be a max or a min, you could have a sign change there, and something could be happening at x equals 0. And I'll show you an example of what I mean in a second, but let's keep going with the problem. So we're gonna make our sign chart here, and let's do it in orange this time. So this is my sign chart for f prime. The derivative is 0 at -1 and +1. And at x equals 0, the derivative does not exist. So it's not going to be a min or a max, but we could have a sign change. And we'll look at that in a second. All right, so these are my intervals of where the function is going to could possibly switch from increasing to decreasing. So first of all, I want to find out what it's doing in this interval here. Is Is the function increasing or decreasing? And we could check that by finding the derivative at a point in that interval and seeing if we got a positive number or a negative number. So what is a number in the interval of negative infinity to negative 2 that we can check out? I mean, negative 1 that we can check out.
-2.
Awesome. I'm so glad you said that. That's probably the best one to do. So if I plug negative 2 into the derivative, what am I going to get? Well, I don't need to know the actual number. I just want to know if it's positive or negative. So looking at the derivative right here, I'm going to do the bottom first. If I plug in a negative number into the denominator and cube it, it's going to stay negative. So the bottom's going to be negative. The numerator, if I plug in a -2 and raise it to the 4th power, it's just going to become positive. It's going to be 16 times another 2 is going to give me 32. 32 minus 2 is still going to be positive. So positive divided by negative will give me a negative value. So the derivative is negative here, which means the actual function is decreasing in that interval. All right. What's happening from -1 to 0? We got to plug in a number between -1 and 0, and let's use -1/2. If I plug in -1/2, what happens? So the denominator will still be negative because if you plug in a negative to a cubic, it's going to stay negative. If I plug in, if I do -1/2 to the 4th power, that's going to be -1/2 times -1/2 times -1/2 times -1/2. -1/2 4 times. So it's going to be a positive number, but it's going to be 1 over 8, 16, 4, 8, 16. So that's going to be, where am I? So it's going to be 2 times 1/16, which is 2/16. So that's just going to end up being 1/8 minus that 2, which is going to be a negative number. So a negative divided by a negative is going to be a positive number. So the derivative is positive in this interval. So the actual function is increasing. Okay. We got to do the same thing from 0 to 1. Let's pick a number between 0 and 1. 1/2 is the one that I'm going to choose. If I plug out the 1/2 into the denominator, you guys tell me, is the denominator going to be positive or negative? I'm plugging in 1/2 into the derivative.
Positive.
Awesome. And if I plug in 1/2 into the numerator, I'm going to run into this situation again and get a negative number. So a negative divided by a positive is a negative. So the derivative is negative from 0 to 1. And that means the function is decreasing. Okay. And then what's happening from 1 to infinity? Let's use a number like 2 to figure out what the derivative is doing there. So if I plug in a number like 2, the denominator is going to be positive because a positive number cubed is positive. The numerator, it's going to be the same situation up here. 2 to the 4th times 2 is going to be like 32. 32 minus 2 is 30. It's a positive number. So we're going to get a positive number here. Okay. So what we are finding out here is the relative extrema, and that happens when we have a sign change. So the function at first is going from decreasing to increasing. So that means we have a relative min at -1. Now be careful here. The function is going from increasing to decreasing, but 0 is not a critical number. So this is not going to be a mech, not going to be an extrema, and we'll see in a second why. Even though we had a sign change, it wasn't a critical number. But the function did go from increasing to decreasing, and at 1 it went from decreasing to increasing again. So we have another relative min. So my function has 2 relative mins but no relative maxes. So let's answer the question now. Find the extrema, or the relative extrema of the function. So f has a relative minimum at -1, comma, we got to plug a -1 in. If I plug -1 in, that's going to be the numerator will be 1 plus 1, which is 2. Negative 1 squared is still 1. It's going to be 2. And we're also going to have a min at positive 1. And if you plug 1 in, you're going to get the same output of 2. Right? No relative max. Because x equals 0 is not a crit. Okay. Let's look at the graph so we can kind of see what's going on here. Does anyone have an idea how you could possibly have a sign change, but not necessarily be a relative extrema?
A sign, like a negative, like a negative to a positive. Is that what you're asking?
So the function is so right here at 0. What's going on right here is the function is going from increasing, so the function is getting bigger, and then it's getting smaller, so increasing to decreasing. How come that's not? I'm telling you that it's not going to give us a relative max. And my question to you is, how is that possible that the function can go from getting bigger to getting smaller, but not create like a hill, not recreate like a peak? I'm sure you guys are flooding Desmos right now and curious what this graph looks like.
I'm just trying to figure out, and I don't have a clue.
All right, so let's see what the graph. Maybe the graph will give us the graph will kind of show us what's going on here. Oh, we got the chat's blown up. Oh, love it! Someone hit the nail right on the head. You could have an asymptote there. And at an asymptote, you're not going to have a relative max or a relative min. So this is going to be kind of a tough graph to see it, but this is kind of what the graph looks like. I'm just going to insert it. What's going on here is we have our two relative mins right where we said at -1. At -1, 2 and +1, 2. But there's no max because right here we have a vertical asymptote. So that's how you can have a sign change. The function's increasing right here, and then it's decreasing. So let me kind of draw that a little bit nicer. So if this is what my function looks like, it's going from increasing to decreasing, but because we have an asymptote here, you're not actually getting a relative max. Does that make sense now?
So do you always want to put 0 in the chart, even though it's not a critical number?
No, the reason why I put 0 in the chart is not because it wasn't a critical number, but because the derivative didn't exist there. So anywhere where the derivative doesn't exist, or the derivative is 0, you want to put those numbers in your sign chart. So for us, those numbers were at ±1 and 0. Now, just you have to recognize that 0, although the derivative didn't exist at 0, it was not a critical number because you can't plug 0 into my original function. So you're not going to have an extrema there, but what you could have there is a sign change. And that's what happened. We went from increasing to decreasing. And if you didn't catch that, if you just looked at if you just made a sign chart with just the critical numbers, so if I just did -1 and 1, you would have recognized that it's negative here, positive here, and then between -1 and 1, if you plugged in 0, you would have gotten an error. If you plugged in 1/2, you would have gotten a minus. And then you would have thought that there's no sign change right here. If you plugged in -1/2, you would have gotten a plus. but then you wouldn't have realized that there was actually a sign change here. So that's why you still want to test those numbers to see what's going on.
I'm just wondering if there's ever going to be an equation where it doesn't exist isn't going to be when x is 0.
Sure. If the derivative was this, 1 over x minus 1. Suppose I had a function where that was the derivative. The derivative does not exist at x equals 1, right?
Okay, that makes sense.
Yeah. Good question. Okay, so all right, last example, and then I'll let you guys work on some problems. Find the relative extrema of this function. So take a second to copy down the function, and we'll do it together. Okay. So we're going to find the relative extreme of a nice trig function. We have f of x equals 1/2 of x minus sine of x on the interval 0 to 2 pi. Here we go. Where do we start? I want to find the relative extrema. What do I need to find?
You start by taking the derivative.
Okay, that's a good way to start. And why am I taking the derivative again?
Find the critical points.
Perfect. Because if there's a relative min or max, it's going to be at a critical point. So that's what we're finding. To find the critical points, we need the derivative. So what is the derivative of this function? You guys can either say it out loud or you can let me know in the chat. But this is a function that we should be able to differentiate quickly. All right, I've got one person. Two people. Three people. All right, correct. So the derivative is going to be 1/2. The derivative of 1/2 x is 1/2, and the derivative of sine x is cosine x. Okay, so the question is, where does this, I want to know where the derivative is 0 and where the derivative does not exist. Just going back to our original function, this function exists everywhere. I can plug it, we're on the interval from 0 to 2 pi. So we're only going to look at numbers between 0 and 2 pi. We're not going from negative infinity to infinity. Between 0 and 2 pi, everything that's going to happen is going to happen there, and then it just gets repeated. The 1/2 x part is going to be defined anywhere, so we're just looking at numbers between 0 and 2 pi. So when does the derivative, which is 1/2 minus cosine x, equal 0? Add cosine x to both sides. So that's when 1/2 and cosine are the same. So for what value between 0 and 2 pi does cosine of x equal 1/2? This is one that we can do in our head. So this is like a unit circle thing. Right. This angle, pi over 6, is 1/2 root 3 over 2. And remember, cosine is the x coordinate. So this angle right here, which is pi over 3, excuse me, if I take the cosine of pi over 3, that's when I get 1/2. So I get x equals pi over 3. There's another place on the unit circle where x is pi over 3, and that's down here, because this would be the point 1/2 negative square root of 3 over 2. And what angle is that? What angle is this now? It's got to be between 0 and 2 pi. So it's 1 pi over 3 is there. This is 2 pi over 3. This would be 3 pi over 3. 4 pi over 3. 5 pi over 3. Okay. So those are the two places, those are the two angles where the cosine of those two angles will give me 1/2 between 0 and 2 pi. You could have also gotten one of them by just doing, if you're ever trying to uncosine something and you got something not easy like 1/2 that's on the unit circle, you could have just done the inverse cosine of 1/2, and that'll tell you what x is. Or some people call it the arc cosine. But anyways, use the unit circle. So these are my critical numbers. This last point, the derivative does not exist. The derivative is going to exist everywhere. There's no number that you can't plug into cosine. You could take cosine of 0, 1, 2, 3, 4, 5, 6, 7, 8. You can, cosine of x, you can plug any angle you want into that. So f prime exists everywhere. Okay. So we have our critical numbers. So Kevin, we found the critical numbers. What should we do with those critical numbers?
Lay them out and test some points.
You got it. Let's make a nice little sign chart for our derivative. We have pi over 3 and 5 pi over 3. So at those points, the derivative is 0. So that's where we could have our relative extrema. We just want to know what the function is doing. Is it increasing, then decreasing? Is it increasing the whole way? What's going on here? So what's the number between, oh, and by the way, this doesn't go on to infinity. So this is, I got to pick a number between 0 and pi over 3. And I got to pick a number that doesn't go past 2 pi when I get to the end, because I have a limited interval here. But that's not a problem. So what is an angle between 0 and pi over 3, or just a number between 0 and pi over 3? So I would say we have two fair options to go with. There's a bunch of numbers that are bigger than 0 and less than pi over 3, but we can either use pi over 2 or pi over 6, and I'm going to use pi over 6. All right, so pi over 6 is right over here. If I plug pi over 6 into my derivative, which is right over here, it's going to be 1/2 minus cosine of x. So it's going to be really 1/2. I'm just interested if it's positive or negative. So if you put it in your calculator, that's fine. Minus cosine of pi over 6. The cosine of pi over 6 is the x value of that point, which is root 3 over 2. 1/2 minus root 3 over 2. Is that positive or negative? Is 1 minus the square root of 3 a positive number or a negative number?
Negative.
Negative, good. Right, the square root of 3 is a little bit bigger than 1. So you can put that in your calculator. But we know that the function is decreasing here. And then what happens after pi over 3? So we need to plug in a number to the derivative that's between pi over 3 and 5 pi over 3. So somewhere between these two angles, I'm going to use pi. That's like an easy number to work with. So it's going to be 1/2 times pi minus, what's sine of pi?
Zero.
You got it. So 1/2 times pi minus 0 is 1/2 pi, which is a positive number. And let's finish it off. We need to find a number that's between, let's go red again. That's between 5 pi over 3 and 2 pi, so something between these 2 points. So what's an angle between here? Does anyone have an angle for me?
Seven pi over 4.
Yeah, that'll work. I was actually going to do something different, but yeah, this right here that would be 7, right? That's because 8 pi over 4 would get me around the circle twice. Because that'd just be 2 pi. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. I miscounted. 1, 2, 3, 4, 5, 6, 7. Yeah, no, you're right. 7 pi over 4. So let's plug in 7 pi over 4. All right, let's do it. So the derivative is 1/2 minus cosine of 7 pi over 4. The cosine of 7 pi over 4 is root 2 over 2, right? So is that going to be positive or negative?
It's gonna be negative. Square root of 2 is 1 point something, right?
Yeah, the square root of 2 is definitely bigger than 1. SQRT of 2 is about 1.4. So that's negative.
Yeah.
All right. So what this tells me is that the relative extrema of my function, I have 1 at pi over 3, and I know I have 1 at pi over 3 because it goes from decreasing to increasing. So we're going to have a relative min. And then at 5 pi over 3, the derivative is 0, but the function before that was increasing, and then it was decreasing, so we have a relative max. So we can answer our question. F has a relative min at pi over 3, comma. If I plug pi over 3 into the original function, remember the original function, what do I get? And I'll be honest with you, I don't think it's a nice number because of the 1/2 x, so I'm just going to look up my answer, whatever I got last time.
That's right, Canflow. You can open the quiz tab. No worries.
I mean, there's nothing new there. These are just the quizzes we've taken already. So if I plug in pi over 3, the height is negative 0.34, approximately. And if I plug in 5 pi over 3, this is the relative max. At 5 pi over 3, comma, what happens when we plug that John into our function? 3.48. Okay. So, sorry, this doesn't look as neat as it could be. I need to be better. Okay. So, the kind of questions that you guys will be asked is find the relative extrema and find out where the function's increasing and decreasing. So the relative extrema right here. And if I said find out where the function's increasing, you would just tell me it's in this interval, pi over 3 to 5 pi over 3. If I asked you where it was decreasing, you would tell me from 0 to pi over 3 and from 5 pi over 3 to negative 2 pi. We could look at a graph, but I think you guys are okay. We've looked at a few graphs already. So you guys ready to get some problems going?
For sure.
Thanks for trying to hold in the excitement. I'll put you guys into breakout rooms, and you guys just work on some problems for the next half hour. Okay. I'll be here to answer questions, and then next class we'll jump into something called concavity and points of inflection.
Like break